So as you remember from Chapter 8, when sigma was not known, you used t to create your confidence intervals. Well, guess what you do in Chapter 9? Same thing. When we're looking at a sample and comparing it to a population mean, what do we want to do is take a look. Is sigma known? Is your standard deviation known? The population standard deviation. If it is not, then you use t. Again, most common is probably this situation. It's not much different. You're doing everything else the same. The null and alternate are identical. You can look at a p-value still and compare it to a significance level. You can take a calculated value of t and compare it to a critical value of t, and it's the exact same process. The only thing different is coming up with critical t, and calculated t is actually the same exact calculation. So again, we're looking at this. The one thing I have to say though is it's hard to find a t-score using the tables. All you can really do is say it's within a range. It's a lot easier just to do it in Excel, and you'll see that here at the end of these slides. So let's take a look at an example. Here's a great example, because what you have here is, what does your population mean? It's whatever they post as the speed limit. And so the speed limit in this case is 65, and they want to know if people are at 65 or less, which means, is traffic greater than 65 on average when they pass a certain point. So we have a sample of 64 vehicles. We find out that the mean speed is 66.2. Since we don't have a population standard deviation, we have to use our sample here and find out that it's 4.2. And then we want to calculate to see if there's a significant difference between 66.2 and 65. So we know in this case, it really doesn't look that different, but is it significantly different based on the amount of variation that we have here? So that's the data that we have. And if we look at that, we want to calculate your null and alternate. And I'll show you again up on the whiteboard what that looks like. We compute our test statistic, again, identical to the way we did it with Z, except we're using t instead as the known value. And let's see what that looks like up here. So on the whiteboard, I've already got the information on the side. And then what I can do is say, here is our nice little bell curve. Posted speed limit is 65. Are people averaging more than 65? If our significance level is 0.05, that means that's this area here. And then if we look at that, we can come up with different values. And I don't know what t is right yet, but I actually can find out, because all I have to do is take degrees of freedom, which is n minus 1, so that means 64 minus 1. And that, if I find that for 0.05, that will come up with my critical value, which we'll see here in a second. But our calculated would then be, so calculated t is equal to 66.2 minus 65, sample mean minus the population mean, over the sample standard deviation of 4.2 divided by the square root of 64, and that's what that 2.286 is. And then, of course, I can come up with my my p-value that corresponds to that critical t value. And right now, you can see I can just say that it's between 0.01 and 0.025, because you've got in your table, you see 2.387 and 1.998. In that case. We'll use, again, Excel here in a second to come up with that. And so what we do is t.dist would be the way to calculate our p-value for our t-score. And that gives me an upper tail of 0.0128. So I know that's less than 0.05, which means I know, if you look at it on the whiteboard here, and it's out here somewhere, which means this is then the 2286. So my p-value is less than 0.05. We are significantly different than the mean, population mean, which is 65. If we look at this in the critical approach, if we found our critical value of t, that means we go over to 0.05 down to a sample or degrees of freedom of 63. That means that on my whiteboard here, that 1.669 goes here. So since 2.286 is greater than 1.669, we are rejecting the null, which means the null is either equal to or less than 65. Greater than is on the alternate, and what we're saying in this case is it sounds like people are driving faster than 65 in this area, and it is a good candidate for a radar trap. How do you like that? They're using statistics to try to find you on the roads and get you a ticket in the most optimal places. And what a surprise! As you all know, we know there are known radar traps out there, and here's a way of using data to come up with that. What this looks like on our bell curve, again, looks a little bit nicer than what I wrote up on the board, but that's what it is. And that's an example of what you do with when you don't know your sample. When you know your sample standard deviation, you do not know your population standard deviation. So all we know is posted is 65 miles an hour. We go take a sample of 64 individuals. We find out that the mean is 66.2 with the standard deviation of 4.2. Is that significantly more than the posted sign of 65? And we found out, yes, it is. And so that's how we can test, in this case, where sigma is unknown.